So in our last video, we had the following formula for curvature. The formula was that kappa, our curvature, it's the magnitude of t prime over the magnitude of r prime. And so we didn't use this formula last time. And so what I want us to do is redo the last example, but we're going to use this other formula. So find the curvature of the curve given by r of t is 2ti plus t squared j minus 1/3 t cubed k. So the first thing I'm going to do, just like in the last video, I'm going to take the derivative of r. So r prime will be 2i plus 2tj minus t squared k. And if I look in my formula, I'm going to need the magnitude of r prime. So just like I did last time, so I'm going to find the magnitude of r prime. And if you remember in that last video, we found out that it was the square root of 4 plus 4t squared plus t to the 4th, which we showed was the same thing as t squared plus 2. So now, what I'm going to do next, if I look, I'm going to need my unit tangent vector t. So that's what I'm going to find next, is the unit tangent vector t, which remember that's r prime over the magnitude of r prime. So this will be 2i plus 2tj minus t squared k over the magnitude, which was t squared plus 2. And now, again, if I look at my formula, I need t prime. So I need to take the derivative here. And here, because I have t's both in the numerator and denominator, you can get by with doing essentially a quotient rule here. So let's do that. We have the bottom, and then the derivative of the top would be 2j minus 2tk minus the derivative of the bottom, which is 2t, times the top, all over the bottom squared. So then you're going to simplify here in your numerator. So I'm going to get, if I group up all my I terms together, I only have one I term, which is over here. So it's a minus 4t I. And then I have a j term here and here. So I combine those to be a positive 4 minus 2t squared j. And then very finally, my k terms are here and here. So I got to distribute, and then you'll end up with minus 4tk. All over t squared plus 2 squared. And so this is my vector t prime. But I need the magnitude of this vector. So when you find the magnitude of this vector, this denominator here, this is being squared, so I know it's positive. I can leave it out of the square root then. T squared plus 2 squared. And then it'll be the square root. Now square all of my entries. 16 t squared plus 4 minus 2t squared squared plus a negative 4t squared. So you are going to have to FOIL this part out right here. So let's see, I get the square root of 16t squared plus 16 minus 16t squared plus 4t to the 4th plus 16t squared. So if I look, I have two terms that cancel, 16t squared negative 16t squared. And if I simplify, if I factor out a 4, which will become a 2 when you pull it out of the square root, you'll be left with t squared plus 2. So then this simplifies down to 2 over t squared plus 2. So now I'm ready to find my curvature kappa. It's the magnitude of t prime, which we just found, over the magnitude of r prime. Well, the magnitude there divided by t squared plus 2. So kappa is going to be 2 over t squared plus 2 squared. Now this was the same answer that we got last time, but if you use this formula, you won't have to compute a cross product, but you will have to take more derivatives here, which could get more complicated. So here we had to use the quotient rule to compute the derivative. So you might prefer to compute the curvature using the formula from the last video, the r prime and the r double prime and the cross product. That might be a little bit easier than computing it this way, but it doesn't matter. Either way, you're going to get the same answer.